Good morning. We are Katrien Beuls and Prof van Eecke, and we would first of all like to thank the organizers of the 2025 ACL conference for providing us with the opportunity to present our Computational Linguistics article, Humans Learn Language from Situated Communicative Interactions. What about machines? Our article investigates the differences between language acquisition in humans and in machines. It discusses the consequences of these differences and makes a case for an alternative approach that models how artificial agents can acquire linguistic structures in a more human-like manner. Through a selection of experiments, we show that the linguistic knowledge that is captured in the resulting models is of a fundamentally different nature, and argue that this change of perspective provides a promising path towards more human-like language learning in machines. We start from the observation that children acquire their native languages by actively taking part in communicative interactions with their caregivers. These interactions are meaningful, intentional, and situated in their everyday environment. The situated and communicative nature of the interactions is essential to the language acquisition process, as language learners depend on clues provided by the environment to make sense of the utterances they perceive. As such, the linguistic knowledge they build up is rooted in linguistic forms, their meaning, and their communicative function. As children engage in situated communicative interactions, they face two challenges that are considered fundamental to the language acquisition process. On the one hand, they need to figure out the communicative intents of their interlocutors, a process referred to by the term intention reading. On the other hand, based on the utterances they perceive and the meanings that they reconstructed through intention reading, children need to bootstrap a productive linguistic system that enables them to understand and produce utterances they have never observed before. This process of generalizing over form-meaning or form-function pairings is referred to by the term pattern finding. For example, during a communicative interaction with a caregiver, a young child might hypothesize that the observed utterance "bear gone" refers to the observed disappearance from sight of their favorite stuffed animal. This association can be made based on sensory experience and pre-linguistic reasoning alone, without any prior knowledge about the compositional nature of the utterance. When the same child later hears the utterance "ball gone" in the context of a certain spherical toy disappearing from sight, their pattern-finding ability might enable them to infer the compositional structure of the observed utterance. Indeed, the child might infer through syntactico-semantic generalization that the form "bear" associated with their favorite stuffed animal is associated with their favorite stuffed animal, that the form "ball" is associated with a certain spherical toy, and that the form "x gone" is associated with the referent of x disappearing from sight. The constructions that emerge from the pattern-finding process can in turn provide clues for the process of intention reading during future communicative interactions. For example, if the child later observes the utterance "gimme bear" in the context of a request by a caregiver to hand over their favorite stuffed animal, they can recognize the form "bear" related to its meaning and hypothesize that "gimme x" is associated to a request by their caregiver to hand over the reference of x. Pattern finding thus relies on intention reading for providing hypotheses about the intended meaning of observed utterances, while intention reading relies on constructions that result from pattern finding to constrain and navigate the space of possible meaning hypotheses. Importantly, the language acquisition process is communicatively motivated, personal, usage-based, and constructivist, in the sense that the linguistic system of each person is individually built up and shaped by their past experiences and interactions. Through the evolutionary dynamics of creating, strengthening, and weakening associations between linguistic forms and their meanings based on their successful or unsuccessful use in communication, language learners effectively manage to build up a productive linguistic system that is tied to their own physical and cognitive endowment, yet compatible on a communicative level with the linguistic systems of other members of their community.
When it comes to machines, important advances in neural machine learning and infrastructure, combined with the availability of huge text corpora, have led to previously unimaginable progress in the field of natural language processing. The main catalyst in this process has been the advent of transformer-based large language models. The extraordinary performance of these models on tasks that were traditionally considered hallmarks of human intelligence has naturally sparked the interest of researchers in other disciplines, including cognitive science, psychology, and linguistics. Despite their human-like performance on many tasks, large language models learn their linguistic capabilities in a very different way than humans do. The most consequential difference is that LLMs learn from textual data, albeit in huge quantities, without access to communicative interactions that are grounded in the world. In the article, we lay out in great detail that the text internal prediction objective through which LLMs are trained, in combination with the absence of grounded intentional communication, leads to inherent limitations in terms of hallucinations, human-like logic and pragmatic reasoning, data hungriness, and sensitivity to biases. We conclude at this point that the only way out is to have machines learn language under circumstances that are closer to those under which humans acquire their native languages, and thereby bring the situated and interactional nature of human language learning into the training regime of machines. Today's large language models already incorporate to some extent aspects of the situated and communicative nature of language, for example through the use of multimodal input data and the application of reinforcement learning techniques to better align the output of the models to human preferences. In our article, we take a very different perspective on the matter and introduce an experimental paradigm that studies how artificial agents can acquire languages through human-like intention reading and pattern finding processes. We discuss two concrete experiments that operationalize this paradigm and show how the linguistic systems that are acquired by the agent in such a setting are of a fundamentally different nature than those acquired by LLMs. The first experiment focuses on grounded concept learning and shows how a population of autonomous agents can self-organize linguistic convention that can be used to refer to arbitrary entities in their environment. The meaningful, intentional, interactional, and communicative nature of the learning environment facilitates the emergence and evolution of an environmentally grounded and communicatively motivated convention. The second experiment focuses on the acquisition of linguistic structures that transcend the level of atomic forms and concept representations. It implements a tutor learner scenario in which a learner agent acquires linguistic knowledge that is adequate to ask and answer English questions about their environment. This linguistic knowledge consists of constructions at different levels of abstraction which can combine to map between English utterances and situationally grounded executable meaning representations. These meaning representations are grounded in the physiocognitive endowment of the agents, their shared environment, and their communicative tasks and intentions. The experiments show that the linguistic systems that are built up by the agents through situated communicative interactions are of a fundamentally different nature than the linguistic knowledge that is captured by LLMs. The agents' acquired constructions are directly motivated by their communicative function rather than by the collocational behavior of linguistic forms. The constructions can thereby be used to comprehend and produce linguistic expressions without relying on textual prediction, and the meanings of linguistic expressions can be conceptualized and interpreted with respect to the communicative tasks and environment of the agents. They thereby steer clear of the hallucination effects that characterize text prediction-based models. As a result of the rich nature of the learning environment, constructions can be acquired in a more data-efficient manner. They are able to capture the communicative function of language, which will ultimately be required to draw human-like logical and pragmatic inferences. Our experiments definitely do not offer at this point an application-level alternative to today's large language models, nor were they ever designed with that goal in mind. We hope, however, to convince the audience that a better integration of the situated, communicative, and interactional aspects of human linguistic communication constitutes the key towards overcoming the limitations of current LLMs, and that more faithfully modeling the situated communicative interactions through which humans acquire their native languages provides a promising path towards more human-like language processing in machines. We would like to thank you for listening and hope to have sparked your interest in reading our Computational Linguistics article, which more elaborately lays out all arguments brought forward in this presentation. If you would be interested in setting up similar experiments, please do not hesitate to get in touch and to check out Fluid Construction Grammar, the framework that powered the simulations run for this article.